Hi, my name is Dr. Megan Stubendek, and I am the Senior Director of Instruction at Arbor Bridge. And this is the first in a series of videos on common student weaknesses that trip us up on the good old SAT. Now, in each of these videos, we're going to be going over tips and techniques you can use, really any student can use, to master the exam and gain a few more points. So today we're going to start with a common math topic. Pretty much appears on every single math section of the SAT, and it's the equation of a line. Now, the most common ways students are familiar with this idea is what's called the slope-intercept form. Now, how does it get that fancy name? I'm about to show you. The first reason is that the equation can show you two attributes of the line. The first is something called the slope. We also refer to this as the m value in the equation. It's always going to come in front of the x value. The second reason we call this the slope-intercept form, we've got the slope there. Let's talk about the intercept. The b value, which is always added onto the m and x, is going to show us where the line crosses the y-axis, which is also known as the y-intercept. Now remember, the y-axis is always the vertical axis on any given graph. So let's take this form and let's take this equation and apply it to a practice problem from the exam. So first of all, we're going to take a look at this line here. And the line that they've given us has 2 points. You can see them clearly labeled, which is very, very nice of them. And we're going to start by labeling our points ourselves. So I'm going to call this point over here my number 1 point, and I'm going to relabel these values that come on the point as my x1 and my y1. And let's label the point over here as my second point, or point number 2. And let's label those values as well as x2 and y2. Okay, pretty easy. Now this is always the first step, and notice here how careful I am about my annotations. This is a hidden idea for the SAT. A lot of students try to cut corners because the time is ticking. Don't. Be really careful about the way you label. Keep your scratch work neat. It will save you from making careless errors down the line that could cost you valuable points. Now, once I have my 2 points picked and labeled, what I can use is the slope formula to find the actual value of that slope of this line. So the slope formula you can see here on the screen asks us to subtract or find the difference between the y values and find the difference between the x values. So let's plug in and let's take a shot at it. So first of all, we're going to say our slope is going to be equal to, and we're going to draw our fraction bar. Let's focus first on point number 2 because it comes first in the fraction. Now, y2, we find here our y2 value is 10, so I'm going to put that right on the top. And our x2 value comes here, and that is a 3, so we'll put that right on the bottom. Now we subtract on both. And let's take a look at our y and x1 values from our first point. Our y1 value comes out over here to be 2, so we plug that right in. And then we have our x1 value, which is over here as -1. Don't forget those negatives. We'll talk about double negatives in a second. All right, now let's simplify this and find the actual value of the slope. Well, our slope comes out to be 10 minus 2, which gives us a value of 8 on the top, and our value on the bottom is 3 minus -1. Now don't forget, if you subtract a negative, it becomes positive addition. So 3 plus 1 is equal to 4. So we simplify, and our slope of this line is equal to 2. All right, now what do we do with this 2? Well, the first thing that we would do with this 2 is we would plug it back into our equation. Now remember, our equation for our slope-intercept was going to be y equals, and I'll keep my colors consistent, m, which was our slope, x, plus, remember we had our b, which is our slope-intercept. Now the one value we have found is this slope value here, which we have found to be 2. So why don't we just go ahead and plug that in? Y equals 2x plus b. Now we still don't know what b is, but the SAT has given us a hint that we can actually find it. So remember what I said, that the b value is the y-intercept, or the place where the line crosses the y-axis. Now, as I pointed out before, the y-axis is the axis that runs vertically up and down. Your x-axis is this little axis here. So let's find, where does the line cross the y-axis? Well, the y-axis is crossed by the line right here. What's the value of this point? Well, I can use all of my rules of coordinate geometry, and I know that my x value of this point is going to be 0 because it doesn't move to the left or to the right of the axis. And I just go up 1, 2, 3, 4 spots or units on the y-axis, meaning that this point is 0, 4. That means my y-intercept has a value of 4, and that's what I can plug in as my b. So what I actually get as my equation in this line is y equals 2x plus 4. Now let's say you're on the SAT and you aren't 100% sure about this answer. Well, there's a way to check. And I always recommend, if you have extra time, check your work, because accuracy means everything on this exam. So the way to check is that we could pick another point on the line somewhere and plug it in. So let's try a new point. Let's try the point where x is equal to 2. Let's see, it's right here. So we've got, goes over 2 units and then up. So I'll just actually label that here. So over 2 units is my x value, and then up 1, 2, 3, 4, 5, 6, 7, 8 will make my new point 2, 8. Now, for any point that lies on this line, all of its values, if you plug in their x value and their y value, should work out in the equation if your equation is right. So let's try it. Let's plug in 2, 8 into our equation. So that would look like our y value is right here, and that's an 8. So 8 equals 2. And what was our x value that we decided? Well, our point here has a 2 for its x value, so let's pop that right in there. And then we had plus 4, it finishes off our equation. Let's double check that math. Does 8 equal 2 times 2 is 4, plus 4? Absolutely. 8 equals 8. Done. This question is done correctly. All right, now let's take it one step further, make it a little bit harder because the SAT likes to do that too. They don't want to make it too easy. And let's try this question here. You're going to notice a few things are similar to the question we looked at before, and some things are a little different. First thing that's similar, you've got 2 points and they are clearly labeled for you. You've also got a straight line, nice and easy. Maybe you might notice that our slope seems to have shifted. Instead of going the line moving up, it's moving and sloping down. So that's a little hint about maybe the slope is going to be negative. But we'll see if that's important later. The other thing you may notice is there are no grid lines for us to actually count units and find different points. So that may be a little bit tricky, and we'll tackle that when we get to it. But let's first start off. Remember, the equation that we want to work with is our slope-intercept. Remember, that shows us our slope, y equals m, our x, plus our y-intercept, which is our b. All right, so this is the equation we're working with. Remember, our step number 1 was to find the slope. Now, let's just use the same colors, same annotations we used before. Let's make this one over here our point number 1 rather, which makes these values our x1 and our y1. And then let's make this point over here our second point, which makes these values our x2 and our y2. Perfect. Okay, we're all set up to go. Now, if you remember back, sort of picturing what we just did, our slope equation, if you remember, shout it out if you know it, is y2 minus y1 all over x2 minus x1. All right, now remember, the next step was to put in our values. So we're going to start with our point number 2 again, because it's first in the equation. So our y2 is equal to 1. Our x2, which we find here, is equal to 4. So we'll put that right on the bottom of the equation. Let's remember it's minus and minus on both. And let's try over to our first point. Our y1 is 7. And our x1 is negative 8. All right, we're not going to fall for the crazy trick of minusing a negative. We're going to remember to add that when we get there, but let's do that next. So our slope, when we actually simplify and solve this, becomes negative 6 on top. And then remember that addition becomes 12 on the bottom, and we get negative 1/2 as our slope. All right, so that gives us our first little part of the equation. Let's pop that right in here. Now we know that y is equal to our m, our slope, was -1/2. We will plug it in, x plus our b. Now, remember the last time we did this question, all we had to do was take a look right here at the place where the line crossed the y-axis. Remember, this is the y-axis here. And we just plugged in the values. But here's where the grid lines become important. The SAT has not been that nice this time. It's really hard here to tell what exactly that y-intercept is going to be. Remember, on the SAT, you can't eyeball anything. You can't make any assumptions. You have to use hard and defined math. It's the most common mistake that students make is they try to sort of cut corners, especially when they're rushing. Don't. It's going to be a trap every single time. So what we have to do now is figure out how in the world can we find this y-intercept? Well, the way that I think about it is think about what clues we actually already have in the material that they've given us. Now, if I can't find the b, let's maybe focus on other variables that we have in our equation. One of the variables we have is a y and the other is an x. Do we have a y and x value anywhere that they've given us? Well, we actually have. We've got the y and x values here for these 2 points. Now remember what we talked about. Any point on the line can be substituted into the equation you've come up with, and it should hold true for that equation. So I'm going to actually start with my point number 2. Now, you may be asking, why? Why would you start with number 2? Well, I actually hate negative signs. They make my math really jumbled. Sometimes I forget to carry negatives and move them around. So I'm going to stay away from number 1 and I'm going to use number 2 because it just happens to be easier for me. If you have easy shortcuts like that on the SAT, always use them. So what do I do here? Well, I'm going to plug in a y value. And what is my y value on this point? Well, it's a 1. So I'll put a 1 here. Then I continue my equation, -1/2. Next, I've hit this variable of an x, and what's my x value for this point? Well, it happens to be a 4, so let's multiply by 4. And then b is the value we're trying to find, so I don't yet have a value for that, so we'll just put a b here. All right, let's do some math. 1 stays the same. What's -1/2 times 4? Well, that is a -2 plus our b. All right, now what you would do is you would add your 2 to both sides so you can isolate that b, and we get 3 is equal to b. All right, now we have exactly what we need in order to solve for this equation. We can pop it right in. So what does that come out to be? Well, we've got y, remember, is equal to our equation here was -1/2 x plus our new b value, which is 3. And this is the equation of the line that you see in the diagram above. All right, so that is the equation of a line. It is a heavy hitter on the SAT and one you should master in order to master the test. Tune in next time and we'll tackle another math question.